Now imagine you had an app that allowed you to upload or snap a photo of an outfit or piece of clothing you like, and it would quickly return recommendations of similar products and where you could buy them from right away. Actually, you don't have to imagine. We already built it, and we call it Fashion Buddy. Fashion Buddy takes users' uploaded photos, searches back to our dataset of existing clothing and apparel items, and then returns the best recommendations to them in real time. And it's all powered by AstraDB and Google's models. Google Vertex AI has powerful embeddings models that are able to vectorize data, which can then be stored within AstraDB for future retrieval. Additionally, along with their embeddings models, Google has their Google Gemini Pro Vision model. This is an LLM that can interpret and understand images intuitively. So, how is this being done, you ask? Just like this. There are a few components here to think about. First, we have Gemini Pro Vision interpreting the image and describing what it sees in the photo. Next, we vectorize the description, store it into AstraDB, and then do the same process when the user takes a photo and uploads it to the app. To get a better understanding of what's really going on here, let's see Fashion Buddy in action. So here's Fashion Buddy. This is our landing page, as you can see, powered by DataStax and AstraDB. Let's go ahead and get started. So first things first, let's go ahead and upload a photo of whatever outfit or style that you're looking for. I'm going to go ahead and take one from my file. Let's do this outfit here. So we see we have a striped sweater, some jeans, some loafers, a handbag. Now I'm going to hit Find Products. So what's happening here is that I've just uploaded the image. The description of the image is then being generated, and that description is then being vectorized. And as you can see, we've got some results back for the photo that I've just uploaded. We have the same striped sweater, maybe something similar to the style or kind of genre of outfit that this person was going for. Some blazers, some jeans, things like that. Another cool feature here is that I can filter the results. So if I want to make it specific to a gender, a specific category, I can do that as well. Additional filters can be added in the future as well. So let's say I select women and perhaps tops and outerwear, and then I'll apply these filters. So now what's happening here is alongside the vector embedding, it's also passing through the filters and sending that to our database to tailor the response. Now you see we get slightly different responses. We still get the striped sweater since it's pretty similar to the outfit we are trying to recreate. But we also get jeans, we also get longer tops, V-neck tops, things that are very similar to the outfit. But hey, let's try choosing a new outfit and actually taking a photo of what I'm wearing today. So I can open the camera. Let's do this. Now we have a photo of myself, and I'm going to click Find Products. And again, I've just taken a photo in real time. It's now generating the description of the picture and then embedding that description. So we have a cute loading screen here as well. So now we have some similar blazers to what I'm also wearing. And again, more business casual types of clothing. So it also recommends things that are similar to the vibe of the photo, but specifically to the main point of the photo, which was the blazer. Now that we've seen Fashion Buddy in action, let's return to the architecture diagram from earlier and take a look at how all of this is really working under the hood. As I mentioned previously, we're ingesting our data into AstraDB. But before we do this, we need to pull the descriptions of each item and generate embeddings based off of those descriptions. Gemini Pro Vision is able to take an image and any prompt that you give it. This prompt then tells the model how or what it should be focusing on in the image. In this case, we prompted it by saying, describe the article of the clothing in the image, ignoring any other aspect of the photo and background. Our dataset also provides us with categories for each item: tops, bottoms, shoes, etc. So we also send this information with the prompt to direct the model to what it should be describing. We save this description along with the details of the product already from the dataset into the LLM. We then send this generated response to the multimodal embeddings model to generate the vector embeddings. Then once this is completed, we store it back into Astra. On the user side, the same thing is being done when they upload or take a photo. The image is interpreted by the Gemini provision model, and the description is then vectorized. Now here's the awesome part, and where AstraDB ties all of these pieces together. We take the user's vectorized request, the image that they uploaded, and perform a vector query on our Astra database to the existing dataset that we had previously vectorized and ingested. We can then tell Astra to give us the top K responses back to the user and display that in our app. The real magic here is just how easily all of these technologies come together. Google and DataStax have had a fantastic partnership over the past few years through the Cloud Marketplace program. With this partnership, we've been able to build solid relationships with our own clients and meet them where they are by integrating the technologies that they're already using. And we continue to do so with the seamless integration of Google's AI models, including the multimodal embeddings model and Gemini provision model that we've showcased today with Fashion Buddy. The multimodal model paired with their Gemini model make it possible for Fashion Buddy to quickly and accurately process photos of clothing in order to query the inventory for similar items. With these tools, developers can take this beyond the use cases of Fashion Buddy by building and improving on it, while also applying the same high-level architecture to different use cases. And the best part is knowing that with DataStax, you have a reliable tech stack to begin with.